Hello YouTube, this is a response video to a video by DarkSkyWatcher74, Tree of Might, claiming a cover-up by the Bradford Robotic Telescope. As we can see in his video, pole shift cover-up still going on, 22nd of January 2013. We're going to listen to the first 4 minutes of his video. If you've already seen it, you might want to skip ahead, but if you want to listen to the detail that we're scrutinizing, you might want to stay with us. Here is the first 4 minutes of his video.
Hey, what's up everyone? It's Tree of Might. It's January 22nd, 2013, and today I'm on the Bradford Robotic Telescope website. This is my.telescope.org. I'm here to talk to you about what I believe is a cover-up going on, and I've mentioned this in a few other videos. Now I'm going to go over here to my account page, and right here is a list of images that I've requested from Bradford Robotic Telescope. Now, 2 of the images I requested today, 2 of the other images I requested on January 6th, which was this image right here from Jupiter, and this image from Saturn. Now right here you can see that they gave me Jupiter as complete, still waiting for Saturn. Why am I still waiting for Saturn? I'm going to get to that in a minute. Let's go ahead and look at this picture of Jupiter that I requested. Let me load this up here. Now here's my job ID, or the request ID. This is the job ID. Okay, we're looking at Jupiter with a 40 millisecond exposure, and we're using the Galaxy camera. Now as I said, I requested this on January 6th. They gave it to me on January 15th as job complete. Now I'm going to go ahead and load up the JPEG image right here, and we're going to go ahead and take a look at what they gave to me. So here we can see all of the information is still there. This is what it looks like. You just scroll down, and this is what they gave me for Jupiter. Now right here on the sides we can see the outline of Jupiter. Okay, and we can still see it's just going to look like a big bright star, even if they didn't give me all this overexposure. Now this is a 40 millisecond shot, and I'm not a professional photographer, but I do know that in order to get overexposure you need to be imaging for too long of a period of time for the object that you're looking at. Now 40 milliseconds is nothing. That's a blink of an eye. That's the camera shutter taking one click. We're just taking an image. It's just like your cell phone. When you point your cell phone at something and you take an image, it clicks real quick, boom, there's your image. It doesn't take an image over a period of seconds or minutes. So this is what they're giving us, are these overexposed images, regardless of what we request from them. Now we can't get the images that we want. We've requested images in so many different formats and exposure times and cameras, and I mean, you name it, we've been there. So that's what they're giving us. And they're giving us this because I believe there's pole shifts going on in the outer planets. They're working their way in. I've been reporting on this. A couple other people have been reporting on this. And I'm going to take you back real quick, and let's go. We're going to look at this from Jupiter real quick. I mean Saturn, my bad. I still need coffee. So Saturn, like I said, I'm still waiting on Saturn. And they're not going to give me that image of Saturn because they know that it reveals things that they don't want us to know. And the same with Jupiter. Now when we're requesting images from these places, that should just give us a normal image, and they give us these overexposed images. That's a purposeful cover-up. They're purposely covering it up, and they don't want to give us these images because they know who the people are that are researching. They know who the people are that are making the videos, that are exposing it, and they will not give us these images. They'll always give us an overexposed image. Now it doesn't matter whether I ask them for 40 milliseconds or 1,000 milliseconds. I get the same thing. I get a big blurred picture. And I'm going to try and show you what I'm talking about here.
So as you can hear for yourself, DarkSkyWatcher74, Tree of Might, is claiming that there's this huge conspiracy, a big cover-up going on with the Bradford Robotic Telescope, and that they're suppressing images and deliberately overexposing images so that we can't get to the truth of what's going on with Jupiter and Saturn. Let's examine these claims further. As you can see, I'm on the Bradford Robotic Telescope, web page. I have an account with Bradford Robotic Telescope, and as you can see, I've done a search here for images of Jupiter on the dates between 14th and 16th of January 2013. I've set the status values of success, and I've sorted by completion time in descending order. As you can see, the results returned have shown images from 028 on the 14th of January through to 2344 on the 16th of January. SkyWatcher was at 0:29 minutes on the 15th of January, this image here. As we can see from the data, DarkSkyWatcher used a 40 millisecond exposure, and he did not choose any filter for this image. Let's have a look at the image. Here is the job data that we saw in DarkSkyWatcher's video. And if we click on JPEG, then we can scroll down and see his image as shown. If we go back to the search results, we can see that on the 15th of January there were 10 completed images of Jupiter returned on that night. We can also see that the different images were set to varying exposure times, and different filters were selected. In the case of DarkSkyWatcher's image, he used a 40 millisecond exposure and he did not select a filter. It was only one of 2 images taken on the 15th that did not select a filter. DarkSkyWatcher74 makes the point that his image is only a 40 millisecond exposure and is just the blink of an eye, as he puts it. But he fails to realize that that camera is on the end of a 14-inch telescope, and as such it gathers a lot more light than what he might expect on a small 4-inch telescope. The reason his images are overexposed is because he has not selected a suitable filter for the exposure time that he's using. If we have a look at the other images that were taken around this time, we can see that there were about 3 images that were taken with a neutral density 3 filter on it. Let's have a look at some of those images, such as this one here. Let's have a look at the JPEG for that image. Here's all the job data for it. And as we scroll down, we find an image of Jupiter that is not overexposed. And in fact, we can see the cloud belts across here. The equatorial belts across the face of Jupiter are clearly visible. If you can't see them, you may need to select your image quality to 720p. Here is another image of Jupiter that was completed at 23:43 on the 16th of January. It was a 40 millisecond exposure time. That's the same time as DarkSkyWatcher's image, but it was set with a neutral density 3 filter on it. Let's have a look at that image. Once again, we can clearly see the cloud belts of Jupiter, and the image is not overexposed. I sent a private message to the Bradford Robotic Telescope Facebook page. I sent them a link to the video by DarkSkyWatcher74. Here is their response to my message. I'm sure you know the answer. His image is overexposed because he's using the wrong settings. You can't compare taking a picture with a 4-inch telescope and a phone camera with taking an image with a 14-inch telescope with 12 times the light gathering power and a super cooled CCD that's designed to capture every photon of light that hits it. Jupiter is bright, and a large diameter telescope magnifies that brightness a huge amount, making it tricky to observe. If you want a decent image of Jupiter, you need to image it through a filter that cuts out most of the light. ND3 works, but I find H-alpha and O3 to be better as they cut out a bit less than ND3. With either of those two, 100 milliseconds will get you a good picture. No filter is the worst choice. And of course you can see the moons on his images, and you can see that they are all in the expected place, and watch them moving from image to image. Once again, this is DarkSkyWatcher74's image on the Bradford Robotic Telescope, and if we check the job data, we see that he did not select any filter type, and this is why his image is overexposed. I actually signed up with the SLU space camera on the 15th of January, the same date that DarkSkyWatcher74 is complaining that he could not get images of Saturn and Jupiter. Let's have a look at the images that I took of Jupiter on my first day on SLU. Here are the images that I've taken of Jupiter. Let's click in there and have a look. The first images that I took, as you can see, were on the 15th of January 2013. The very first image I snapped was at 20:07 and 9 seconds UTC. Now let's have a look at the image that I took about 1 minute later at 20:08 and 32 seconds UTC on the 15th of January. Here is the image that I took. This is Jupiter from the Canary Islands, Dome 2, high mag camera, on January 15th, 2013 at 20:08 and 32 seconds UTC. As you can see, I can personalize my image and date and time stamp it with this data here. When I push apply, this will be added to the image, and then I can download my image and save it, or I can share it to Facebook. Here are my downloaded images of Jupiter from the SLU space camera, and also some screenshots. This is the image that I just showed you, and here is the full-size image. Now if you're looking over here, you'll notice that the date modified is Wednesday 16th of January 2013. However, this was on January 15, 2013. This is because the timestamp on the SLU space camera, of course, is given in UTC, and I'm living in New Zealand, and we're approximately 12 hours ahead of UTC, depending on whether we're on daylight saving or not. So we can see from this image that it's a nice clear picture of Jupiter. We can see the great red spot just here. We can see one of the moons out to the left hand side here. We can clearly see the equatorial cloud belts across the face of Jupiter. So there is no question about getting good images of Jupiter from a good remote telescope site. Now let's go back to the Bradford Robotic Telescope site again. Remember their advice on Facebook about using an H-alpha filter or a 03? I've done a search here for images of Jupiter using the filter 03 on the Galaxy camera. As you can see, we've got a number of results here, and the most recent one was on the 18th of December 2012. Let's have a look at that image. Here's all the job data, and as we scroll down, we can see that this image, unlike DarkSkyWatcher74's image, is not overexposed, and we can make out the cloud belts, and we can see 1, 2, 3, 4 of the moons of Jupiter. Here is DarkSky74's image taken on the 15th of January 2013 compared to the image that we just looked at that was set correctly with an 03 filter at about 100 milliseconds exposure. You be the judge of which image is the correct one. Now I would like to turn our attention to another claim made by DarkSkyWatcher74 in his video. He says here that over the last 5 years our own planet's poles have been shifting 3 degrees a year, which is 40 miles a year. Is this information correct? Just how far in distance is 1 degree of pole shift? A quick Google search for degrees to kilometers will quickly reveal that 1 degree of latitude on the sphere is 111 kilometers or 69 miles. There are a number of entries here, you can check them out yourself. So if DarkSkyWatcher74's claims are correct, that over the last 5 years our own planet's poles have been shifting 3 degrees a year, just how far would that be? 5 years times 3 degrees would equal 15 degrees in the last 5 years. 15 degrees would equal 1,035 miles or 1,665 kilometers. Now the Earth's actual tilt, that is the amount that it is tilted on its axis, is 23.5 degrees. So if there was 15 degrees change over 5 years, that would mean that the Earth had either changed from 23.5 degrees to 38.5 degrees, or that it had gone the other way and had changed from 23.5 degrees to 8.5 degrees. A change like this would be absolutely catastrophic for the Earth, and it would be unmistakable. It would also be very obvious because all of the planets and stars, the Sun and the Moon would be completely out of place in our sky. Not only that, the pole star in the northern hemisphere, Polaris, would be clearly out of place. Now, before anyone jumps on me and claims that DarkSkyWatcher74 was talking about magnetic pole shift and not actual pole shift, let's just have another quick listen to what he said in his video.
And they're giving us this because I believe there's pole shifts going on in the outer planets. They're working their way in. I've been reporting on this. A couple other people have been reporting on this. And I'm going to take you back real quick and let's go. We're going to look at this from.
Now, you can't use images of planets to show magnetic pole shift. It doesn't work like that. You cannot see a magnetic pole shift in an image. You can only see the actual tilt of a planet. So it is clear that DarkSkyWatcher74 was talking about actual pole shift, that is the amount that the axis has tilted, rather than magnetic pole shift. Now, I think it's fair to say that after reviewing the claims made in DarkSkyWatcher74's video of some great conspiracy to cover up these images and not supply images and overexpose them, and also his claims about the planets tilting, and his claims about pole shift, that the poles have been shifting 3 degrees a year, which is 40 miles a year, he says, which is clearly incorrect. I think it's pretty clear that he really has no understanding of what he is talking about. He doesn't know how to set the images in the robotic telescope that he's using. He doesn't know how to read the images, and he has a poor understanding of astronomy. So I suggest that anybody who is looking to DarkSkyWatcher74 Tree of Might as somebody who knows what he's talking about might want to think again and maybe do some research of their own and check these things out and see if these claims being made stack up, because clearly they don't. The images of Jupiter and Saturn are available. I suggest to people that they can either sign up with the Bradford Robotic Telescope and take the time to find out how to set the images correctly. Even send Bradford Robotic Telescope a message. They've got a Facebook page. You can comment on their page, you can send them a message, and I'm sure that they'll be glad to help you. Alternatively, you could put your hand in your pocket and spend a little bit of money. $60 for 3 months is not a lot of money to spend on quality images from the SLU Space Telescope, and you'll be able to get images readily. You won't have such a long waiting time, and you can piggyback on missions from other members, and you can take images at any time. So hopefully this has cleared that up. Once again, check out my Facebook discussion page, Voices of Reason to Explain X or VORTEX. I'll put a link for you in the description area. Thank you for watching.